Hi everyone, welcome to our video on design and implementation of open loop and closed loop control systems using ESP32. This project, developed by us, explores how fundamental control system work with real-time implementation using ESP32. Now, in this project, we build two control systems, an open loop control system using a rotatory encoder to control a servo motor and a closed loop system that automatically controls a heater or cooler based on temperature. Everything is managed by a single ESP32 microcontroller which allows for efficient hardware design and real time feedback. Now, what are control systems? A control system is a system that manages, directs, or regulates other systems using control loops. It is the core of automation from industrial robots to smart appliances. They are divided into mainly two types: open loop, where there is no feedback, and closed loop, which adjust in real time based on sensor data. Now, the project components. So, here the components we used firstly ESP32 as the brain of the system. Now, DST11 sensor for temperature input, relay and MOSFET to control output loads, and rotatory encoder for user input, and servo motor to show output movement, and lastly OLED display for real-time updates. We also include a mode switch to toggle between open and closed loop. Now, in the closed loop mode, the ESP32 reads ambient temperature via DHT11 sensor. If the temperature goes above the threshold, a cooler represented by an LED here is activated. If it drops below, a heater is turned on. This mirrors how a real HVAC system works. Using the rotary encoder, users can adjust the threshold temperature in real time. Now, the block diagram here we represent how the closed loop system works. Feedback from the sensor enables automatic response. Now, in open loop system case, the same rotatory encoder is used to control a servo motor. The motor moves to an angle between 0 degree and 180 degree depending on the encoder's rotation. However, there is no feedback, so the system does not know whether the motor reached the desired angle. This is the perfect for basic robotic system where precision is not critical. Now, the mode switching and code. So, a standout feature is dual mode switching. One encoder press toggles between temperature control and servo control. This allows both systems to run using same components, saving GPIO pins and hardware cost. Now, the programming and code snippet. So, all this programmed using Arduino IDE. So, we used libraries from DST, servo, encoder, and OLED. The code also support Bluetooth monitoring and can be expanded for wireless control. So, now the observations and output. So, the system performed well during testing. The servo motor responded smoothly LED correctly indicated temperature state, and the rotatory encoder worked reliably on both modes. OLED provide real-time updates, making it very user-friendly. So, the applications. This project shows how open and closed loop systems are used in real world, from CNC machines and traffic lights to air conditioners and industrial controllers. With future improvement like PID control and Wi-Fi monitoring, this setup can be expanded for real world deployment. So, thank you for watching.